There are other two technical assistants who will be teaching assistants basically, Ramesh and one more student. They will be also uh, helping you in the coursework. As a part of the PMRF program, Soumya will also be discussing with you people. You have any issues related to this particular course, so you will be able to clarify. If you not, you can send an email. Later, you will discuss with me and we can again clarify your doubts. So good luck to all of you. So now you can start discussing. So it could be a discussion type of thing where you people have some doubts. You can raise the doubts wherever possible. We will try to clear it. Thank you.
Thank you, sir. So, good evening, everyone. I am Somadip, and I am doing my PhD in IISc Bangalore. I am a PMRF research fellow, and I'll be handling this course, Introduction and Advances in UHV Transmission and Distribution, which has been taught by Professor Subbareddy in NPTEL. So, I'll be taking one session per week. I'm audible, right?
Yeah, you are audible. Yeah.
Yeah, thank you, sir. So, I'll be taking one session per week every Saturday from
Maybe I request all the participants to kindly mute their phone so that there will not be any disturbance.
yeah. Thank you. Thank you, sir. So I'll be handling this course and you can tell me of any doubts or any clarifications which you would need in the way of this course. So every week I'll be taking a 2-hour session from Saturdays from 6 p.m. to 8 p.m. Everyone please mute your mic.
Soumya, can you unmute them if possible? Somebody is switched on the
Yes,
mic.
sir. Yes, sir. I have muted them.
Better you can mute them so that you can
Yes,
continue.
yes, sir.
And wherever the students are wanting to clear their doubts, please raise your hand so that Soumya can stop his discussion and then try to answer your calls. Thank you.
Yeah, thank you, sir. So you can tell me every week will be like in the NPTEL we have the lectures designed or designated for each week. So I'll be covering all the lectures, doubts pertaining to all the lectures for that particular week, and the assignments which has already been submitted. I can discuss those assignments if you have any if you need any clarifications or doubts. So today is the first day of this course. So basically I'll be taking up the first week's course content which has been uploaded in your NPTEL login. So basically first I'll give you a brief introduction of this course and then I'll be anyone if you have any doubt you can stop me in between and you can raise your hand. I'll unmute you and you can speak up. So basically this course advances in UHV transmission and distribution. So this course it introduces the recent advances in EHV and UHV transmission and distribution system. EHV stands for extra high voltage whereas UHV stands for ultra high voltage. So this course basically it will emphasize on the learning and the understanding of the new design criteria which are required for the design of the UHV transmission and distribution systems, which basically include the design of your insulators, the different power system components which we have, like the design of the insulators, the protections and the safety concerns. So this course will basically start with an introduction to the importance of EHV or UHV transmission, why we need to transmit our voltage, why we need to transmit our power at such high level of voltages, what is the need of it, what is the advantage of it, and then it will slowly describe you about the present and the future growth of the advances in UHV and EHV transmission in the country and abroad. The discussion on the various components, like I told about the insulators, it can be the transmission towers, the foundations of the towers, the different components which you can see in the substations like the transformers, the line arresters, the surge arresters, the bus bar, all these things will be discussed in detail and the design criteria for this. Uh, so when you are basically transmitting at ultra high voltage, that is voltages which are greater than even 1000 kilovolts. So there you need special kind of protection, special kind of clearances to transmit our power at that high level of voltage. So we'll be discussing in the course of the lecture. You will see it will be discussed, and it will be strengthened. This course will be strengthened by the aid of lectures, practical video demonstrations, and you will get one assignment per week. And you have to solve those assignments within the stipulated time, and you have to submit it in the NPTEL portal. So So I'd like a brief introduction about some of you. Some of you can unmute and you can speak from where you are, what you are pursuing, and then we can start with the discussion. So you are all BTech students. Anyone can respond, or you can type in the chat box if you are not able to speak up. Hello, someone can respond. Mr. Pramod, you can respond. You can unmute your mic.
Good evening,
So
sir.
yeah, you are from which place of the country?
I'm Pramod Kumar, sir. I'm from Andhra Pradesh. I'm working
Oh,
as a the Department of
you are working in.
Aditya College, sir,
Okay,
as an assistant professor.
okay, okay. So, what are your expectations from this course? What do you want to know? Means, basically, all these things you will get in normal books only. But what is your expectation from this course? What extra do you want? Anyone can tell?
Hello, sir.
Yeah. Yes, Amish.
Hi, my name is Bhanu Samir, and actually, I'm a working professional in this extra high voltage and high
Okay.
voltage cables and transmission lines. I have
Okay.
enrolled myself into this course just to know what is the current advancement theoretically in this subject.
Okay.
Um Basically, I'm from Andhra Pradesh, but I'm working in Saudi Arabia.
Okay. 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 Fine. Thank you.
Thank you.
Anyone else you want to talk? Okay. Hello.
Good evening, sir.
Yeah. Yeah. Tell me.
Good evening, sir.
Yes.
My expectations from this course is that the human values what we are teaching to the students in the class, we are following that own textbook and also our own modules.
Can you
So it
please
will,
introduce yourself? Can you please
yeah.
introduce yourself?
Good evening, sir, and good evening, everyone. My name is Rajlakshmi. I'm working as an English assistant professor in Hyderabad Institutions of Technology.
Okay.
And regarding this course, I was interested to learn about the human values and what are we doing. According to our college JTU criteria and all, we are following certain textbooks only.
Hmm.
Uh, I hope that this program will help me learn something new what we teach students in the college.
Okay. Okay. Fine. Thank you. Anyone else? Okay, so first I'll give you a brief outline of this course. I'll share my screen. You just tell me whether it is visible or not. Okay. I'll give a brief outline of the course. What are the different topics which will be covered that you can see from the NPTEL site anyway. But still, I'll give it. Everyone, please mute your mics. Are you able to see my screen, everyone? Can someone please respond?
Yes, sir.
The screen is visible, right?
Yes, sir.
Okay. Thank you. Yes. Yes, Sumit Kumar Prasad, you want to tell anything? Please, if you want to tell, you can speak. Otherwise, please mute your mic. Hello? Please mute your mic. Sumit Kumar Prasad, you want to say something? Fine. Okay. So first I'll give you a brief outline of this course. So basically we will have 8 weeks of classes, each week consisting of 5 lectures. 8 weeks of class, each week will have 5 lecture videos. Each week we'll have 5 lecture videos. So within that week you need to complete those 5 lectures. You need to see those 5 lecture videos. You need to solve the assignment which will be updated in your NPTEL login. You have to submit the assignment within the stipulated time, and you have to come to this doubt solving session to clear any doubts which you have. Okay, so fine. So this is the first week. So first week 1. So basically it will be on transmission system development and issues. Is my screen visible to everyone? Hello?
Hi, sir.
Sorry.
Okay. Okay. Thank you. So transmission system development issues. What are the various issues which are related to the development of transmission systems? So as you all know, there are 2 types of voltages by which we can transmit the power. One is HVAC, which is high voltage AC transmission, and the other is high voltage DC transmission. So basically, so we need to understand why we use HVAC power for transmission, or why we need to use HVDC power to transmission. So we will be talking. So in this week 1, we will have 5 lectures, right? So first will be lecture 1, which will be on advantages of HVAC or HVDC transmission, and introduction to grid management. So here we will be, first lecture will be basically on the history of, basically if you look at the lecture, it will be on the advantages and disadvantages of transmitting power in through high voltage AC and high voltage DC. What are the various design constraints when we switch to HVDC? What are the various design constraints, advantages, disadvantages when we switch to HVAC? Up to a certain, if you look through the lecture, you will see that up to a certain distance, I think it is about 400 kilometers, this transmission system HVAC is more economical, and after 400 kilometers we can see that HVDC is more economical. There is a graph which has been given in the lecture, which has been shown, which plots the cost of transmission of HVAC and HVDC, uh, how is it varying with the distance of transmission. So from there we can see that after 400 kilometers, HVDC is more economical. So for longer transmission systems throughout our country, we use HVDC transmission system, and for distances less than 400 kilometers, we have the HVAC system. So what are the various advantages and disadvantages in the HVAC and HVDC transmission? We need to understand that before we can proceed into further lecture. So the first lecture, basically it will be telling you about these advantages, disadvantages. Also it will tell you the history of development of power grids in India. We have basically 5 power grids: the northern grid, the southern grid, the eastern grid, western grid, and the northeastern grid. So basically how there is a synchronization, how synchronization is developed between these grids for the transfer of efficient and smooth transfer of power. All these things will be discussed in this lecture. So then basically it will start with the history of power distribution, the history of creation of these grids after the independence of our country. And today we can you can see the from the north to the south, covering from right from Jammu Kashmir in the north to Kanyakumari in the south, we have a power network of 3,200 kilometers, and which is in if we compare it to the scenario power scenario of the world, it is within the top 6 or 7 countries, India's power network. So then you will see the different sources of energy. What are the different sources of energy? Nowadays, you will very fluently hear that we have the renewable sources of energy which are coming, which are replacing our non-renewable or the exhaustible resources. Like exhaustible resources, basically now we are using the coal, petroleum, all these things. But after a period of, but that resource is limited. After a span of a particular time, we that will be depleted or that will be exhausted. So we need to find some alternative energy sources like solar, wind, hydro, thermal, which can provide us energy when this coal, petroleum all are gone. So we will see what are the advantages of the renewable, what are the challenges which are faced. Hello?
Hello.
Yes, who is this?
I am Venkatesan joining in.
Yes, sir. Please tell me.
No, I am also enrolled on this course.
Yes, sir. Okay.
Yeah.
Yes, sir.
So I clicked from the link and added myself here. Sorry, I'm a little
Okay.
late.
Okay, fine, sir. No issues. I am actually a PMRF scholar, a PhD research scholar at IISc Bangalore, and I am a teaching assistant for this course. And I'll be taking this live session every week from Saturday from 6 p.m. to 8 p.m. So you can go through the lectures, and if you have any doubts, any clarifications you need, you can post it in this class, or if you are not free, you can send me through email. I'll try to clarify it as soon as possible.
Yes, sir. Thank you very much, sir.
Thank you, sir. I'll continue, sir, if you don't have
Yes,
any issues.
please do, please do, please do.
Yeah, okay. Thank you. Can you please mute your mic, sir?
Yeah, will do.
Thank you. So as I was talking, this first lecture will be on this renewable, non-renewable resources. What is the importance of renewable resources? What are the challenges which we are facing while integration of these renewables with our power grid? So these are basically discussed. A brief overview is given in the first lecture. That is the first lecture of first week. Okay. So now basically we will move on to the second lecture. So first I'll be giving you a brief outline of what are the course contents, and then I'll be taking up doubts of content related to first week. Okay, today. Okay, so first is the second lecture is basically it is about the important components. The important components of our transmission and distribution system. So if you look at our substation, or if you look while traveling through train, the most important component is the transmission line, right? So the transmission line, then we have, you see some insulators, some stack of rings, disc type structures which are hanging from this transmission line, which are known as these insulators. So this is one of the most important components, the insulators in the in our power system. So these insulators are exposed to different weather conditions, right? It will be exposed to rain, or in our colder countries like in USA or in Europe, we need to, it will be exposed to ice, fog, snow. So we need to test these insulators. We need to test these insulators for different kind of conditions. So the study of this, the different testing of insulators under different conditions is known as the condition monitoring study. Then we have aging studies in insulators. So what do we mean by aging studies? So these insulators, when they are exposed to different stresses, by stress I mean voltage stress here, right? So continuously power is flowing. So these insulators will be exposed to different kind of voltages. Sometimes lightning may strike on the transmission line. Sometimes some switching, some faults can occur in different parts of the power system, and that can travel as a wave to the insulator. So basically, then the insulator will face different kind of situations. So we need to simulate these situations ahead of commissioning the insulators in our power lines in our laboratories. So that is basically the use of a high voltage lab. Apart from the research activities, a high voltage lab basically tests these insulators under different conditions, which is known as condition monitoring. So initially, before the era of condition monitoring, we had time-based monitoring. That is, after every some particular instant of time, we used to monitor the health of these power equipment like insulators, transformers. So from that, we have switched. We have switched to condition-based monitoring. That we have decided, the engineers rather, the high voltage engineers or electrical engineers, they have decided that they will start this monitoring only when required. According to the condition of the equipment, we will be monitoring our uh, equipment. So that is a bit apart from this course. That condition monitoring section is not covered in this course, but I'll give you a brief idea why we need to do condition monitoring. That is, so condition monitoring will test the equipment under different conditions. Like these insulators, take for example these overhead insulators which are hanging from these transmission lines, that will be exposed to sunlight, and then there will be pollution. Like transmission lines will run everywhere in our country, even beside the factories. A factory which emits different gases, different smokes, which can, these particles, the smoke particles or gaseous particles, this can get deposited on the surface of the insulator, and that will affect the performance of the insulator, because insulator should be insulating the conductor from the line, right? So what is our aim? That gas particles or this is called pollution. So from air pollution, this surface of the insulators will be polluted, or will be, rather we call it contaminated. And this contamination is one of the most hazardous effects on these insulators. And from beforehand, before commissioning or installing the insulators in the power lines, we need to test these insulators under different conditions. Under rainy conditions, we can simulate artificial rain in our high voltage laboratories, and we can simulate what are the we can simulate how the insulator is performing. There are different types of insulators: polymeric insulators, composite insulators, then we have glass insulators which are used in Europe. So basically we need to test all these insulators before commissioning it in our power lines. So this is about the insulator. One more important component is the tower, the UHV towers or the UHV towers which we see. So the foundation of this tower, it depends on again several factors. These towers are the design of these towers. There is a dedicated module in this course which concerns only about, which discusses only about the design of towers, the design of EHV and UHV towers. So there it has been taught how optimization of the UHV towers are being developed. Okay, so this is about the lecture 2 of the first week. So these important components of our transmission and distribution system, basically here we have talked about the different components of the EHV and UHV transmission and distribution system. So insulator is one component. Another component is, I told, the EHV and UHV transmission towers. Then we have another component which is the ground wire, right? The ground wire you have seen at the top of the tower. That is basically when there are different types of over voltages, right? One is lightning over voltage and one is switching over voltage. So I'll stop here once to see if you have any doubts. You can stop me anywhere. Anyone has any doubts? Anyone has any doubts? Any doubts regarding solving the assignments? Anything? Okay, fine, I'll continue. So this another component I told, the ground wire, right? These ground wires are basically a protection system which are installed on the top of the towers, and which is for dissipating the surge voltages or the over voltages which come in the which can destroy our power system. Then again we have the ground wires. Then we have the most important component, which is the conductors or the phase conductors. The phase conductors we have in the transmission system, and that basically transmits the power through these transmission lines. Okay, so these are about the different components in the power system. So next, this third lecture, it will be on insulation coordination. So anyone is familiar with the term insulation coordination? What is it? Anyone? What is insulation coordination? Anyone can briefly describe? No one is responding. Then I'll call one by one, because only I cannot speak. Everyone has to participate in the lecture. Yeah, I'll call. Hello? I'll go by this. Abhinaya, can you respond, please? Hello? Abhinaya is there? Yes, Pramod, you want to tell anything?
Yes, sir. Insulation coordination design of
Your voice is not audible. Can you again repeat? Or you can yes?
proper design of an insulation cover for particular working voltage.
Okay. Okay, fine. Anyone else you want to share your thoughts? Mr. Venkateshan, anything you want to add, sir?
Insulation coordination is rather a grading of the insulation breakdown at various points, so that the most valuable equipment are protected. And if breakdowns do occur due to surges, the less expensive or less vulnerable items get breaks down first. So there is a
Yes.
grading of the insulation capability in the various equipment in the transmission system. I believe that is
Yes.
what coordination is all about.
Yes. Absolutely correct. So basically insulation coordination, it will be the grading of insulation. That is, as Mr. Venkateshan correctly pointed out, so we have different components in our transmission system and distribution system. So there we need to decide which component is more valuable, which one we want to protect first, and which one we can sacrifice. So if you see, there are different VT curves. I'll draw it once again, so for making you understand. So from some voltage time curves, one second. Okay. So if you see these VT curves, the first curve, I'll draw the curves and then I'll explain one by one. Okay. So I'll draw the VT curves of different equipments with different colors. So that will be easy for you to understand. So the lowermost curve, that will correspond to lightning arrestor. This will correspond to a transformer. This will correspond to your line insulation. And this will correspond to the most valuable equipment, which is the bus bar. The insulation of the bus bar, that is the most valuable, and we want to protect that. So if any over voltage comes, we are designing the insulation, the basic insulation level of different equipment such that it attacks the lightning arrestor first and the current is dissipated. It will not further attack the transformer because the breakdown voltage of the basic insulation level which we are providing to the transformer, line insulation and busbar insulation is much higher than our lightning arrestor. So whenever a high voltage comes, it will first attack the lightning arrestor and the current will get dissipated. So basically, this is in brief the idea of insulation coordination. You can look into the lecture 3 basically of first week. So you will get a better understanding of what is this insulation coordination. This is in very short I described. You can you can go through the lecture and you can understand what is actually insulation coordination. So next we will have in this lecture 3 only we will have the different over voltages in power system. So can someone tell what are the different over voltages in which our power system can experience? Anyone? Okay, one second. Someone has a doubt, I think. Anyone has raised their hands? Yeah, Samir, you want to ask anything?
Yes, sir. I was having a doubt in this insulation coordination VT graph.
Yes.
Actually, we have shown that the what is it lightning arrestor is the first line of defense
Hmm.
because whenever any over voltage comes, lightning arrestor handles it and it comes first. Then the transformer.
Hmm.
Sir, my doubt is usually in a substation we try to protect the transformer by all means. So how come line insulation is more protected than the transformer?
That is correct actually. Uh, I'll think and I'll get back to you, Samir. Okay.
Yes, okay.
So what was Samir's doubt actually? He told that transformer is the by any means we want to protect this transformer. So here basically we have not shown all the components. There are different other components in the power system also like suspension insulators, the post or pin insulators, which will have our this insulation level much lower than the transformer. But this busbar, you think of the busbar insulation. Okay, transformer insulation, we know it is one of the most important. Yes, but if one transformer insulation fails, the power of a particular region can be cut. But there will be some backup transformers also, right? So one transformer failure doesn't mean the entire substation will go out of power. But if the busbar insulation or the line insulation goes wrong due to say a lightning strike or any kind of over voltage, then we will face a total power cut or power this shutdown of the entire community. But one transformer, if it will try to protect it, but if for any reason it gets failed, then obviously we'll have some backup transformers also, so which will protect this. So I think this is the actual explanation, but I'll look into it and I'll get back to you, Samir. Is it fine?
Yes, sir. Yes, yes.
Yeah. Thank you. So what I was talking of the different over voltages in power system. So anyone can tell, you can lower your hand, Sabir. Okay, fine. So what are the different over voltages in power system? Someone can tell what are the different over voltages in the power system?
Sir, all voltage due to lightning.
Yeah, over voltage due to lightning. Okay, fine. One is okay. Anything else?
Switching
Anything else?
voltages,
Yeah,
switching surges, sir.
yeah. Switching surges, lightning surges. So these are the two most important over voltages which we come across in our power system, right? One is the lightning over voltage and the other is the switching over voltage. Apart from that, we also have some other over voltage which are known as temporary over voltage. So we have the VFTOs. You have heard of that? Very first transient over voltages. It is similar to the impulse voltages, but that will be of the duration of these voltages will be very less. So in lightning over voltage, can you tell what is this time period, the the rise time and the fall time of lightning over voltage? Anyone? Any idea? Anyone? The wave shape of lightning over voltage and switching over voltages. Any idea?
1.2 stroke by 50.
That is for lightning, right?
Yes.
And
Switching
for
it is
switch,
250 by 2500.
yeah. So you have an idea on what is the front time, what is the tail time, right? So front time basically it is the time which is required for the voltage to rise from 10% to 90% of the voltage. The 10% to 90% of the maximum voltage. So that is called as the front time. And what is the tail time? Tail time is the time which is required for the impulse voltage to drop from the maximum value to 50% of the value, right? So basically, can you tell me what is means in lightning over voltage? Why we are more concerned about this lightning over voltage and switching over voltage? What is the main factor in these over voltages that distinguishes it from any other kind of voltage? So, what is causing the actual harm in the power system from this lightning and switching surges? Anyone can tell?
Their insulation will be damaged to a particular
Why?
level.
Why insulation will be damaged? What is causing the harm? Is it only the
Sir,
magnitude
I
of
think
the voltage?
yes,
Yes.
sir. I think the magnitude of the voltage is very high in lightning surges.
Yeah, yes, correct. Magnitude of voltage is one factor, but what is the more important factor? Apart from the magnitude of the voltage, what is causing the actual harm?
It is a traveling wave.
Yeah, correct. So traveling wave is, yes, traveling wave is correct, but I'm looking for a specific answer. Any guesses? Anything you can think of? So what basically, when any kind of high current or high impulse voltage, if it strikes any equipment, so basically that will, why it will damage the equipment? Is it basically, is it just exceeding the voltage level, or is it something else is there? Any cable, you think of any high voltage cable or any transformer, the insulation of the transformer, oil paper insulation, what is causing the actual harm? It is not only the, yes, magnitude of the voltage is one factor that is exceeding the insulation level of that particular equipment. I agree to that, but something else is there. So, yes,
The
anyone?
rate of the rate
Yes,
of rise of the voltage.
yes, correct. Rate of rise of the voltage. So yes, rate of rise of the voltage is the correct answer. So what is rate of rise of the voltage? It is dV by dt, right? That is the change in voltage by the change in time. So if we have this lightning impulse voltage, you are telling this time is 1.2 or 50 microseconds, right? So if it was not in the order of microseconds, just for assumption, hypothetically you take it 1 by 50 seconds, then would it have caused the same harm as this lightning over voltage, as this microsecond? No, because this sudden change in voltage, that is, it is rising from 0 to the maximum voltage, that is maybe of the order of megavolts, within 1 microsecond, 1.2 microsecond rather precisely. So within this 1.2 microsecond, this sudden increase in the voltage, this dV by dt, change in voltage divided by the change in time, which is of the order of 10 to the power 9. You can not even 10 to the power 9, 10 to the power 12. It will, the dV by dt will go of the order of 10 to the power 12 volt per second, which is very huge. So this rate of rise of voltage or rate of rise of current is one of the most important factors because of which we need to take care of the power system equipment, because this dV by dt, one second, I'll write it down. So dV by dt for impulses, as I was talking, say lightning impulse, you told it is 1.2 by 50 microsecond, right? So if I draw the wave shape, it is like this. So this is my peak value, Vm I am telling, this is 0.9 Vm, this is my say 0.1 Vm. So this is basically my 1.2 microsecond. So you can see from 0 to 0.9 Vm or Vm you say, it is reaching within a span of 1 microsecond. So this dV by dt is very high. That causes damage. So this will basically damage the insulation. It is not only the magnitude of the voltage, rather it is this dV by dt. I am stressing this term because you need to understand this. Okay, so this is about the impulse, the over voltages. Okay, fine. So I'll go to the next topic. The next topic is about lecture 4, is design or selection of insulators. Selection of insulators. Importance of grading and corona control rings. So what is corona? You can, in electrical, obviously not the coronavirus. What is corona discharge? Can anyone tell? Any idea? Anyone?
It is the ionization of atmospheric air around the conductor.
Yeah, correct. It is a partial ionization of the atmosphere or the air around a high voltage conductor. So what is the voltage level, or rather the electric field strength, which is required for corona inception in this normal air under standard temperature and pressure? Any idea? What is the breakdown strength of air? Any idea? Anyone? What is the breakdown strength of air? That is, what is the voltage level or the electric field at which air tries to behave as a conductor or the ionization occurs?
Not able to recall.
Okay. Any idea? Anyone? Under standard temperature pressure, what is the breakdown strength of air?
It's 30 kV per
Sir,
centimeter.
is it around 30 kV
30 kV per centimeter.
centimeter?
Yes, correct. It is under standard temperature pressure, the breakdown voltage of air is 30 kV per centimeter, correct? So once the local electric field around that high voltage conductor, it exceeds 30 kV per centimeter, there will be a ionization around that conductor, which we call as a visible ionization. If the entire atmosphere is dark, you can see the ionization with your naked eye. So that is known as corona. And these high voltage conductors need to have some protection for this corona discharge, right? So what we have as a protection is the corona control ring, which are also called as CC rings, right? So one second. Okay, so this is all about this corona rings. So if you go through the lecture, you will have an understanding of what are the corona control rings. So these are basically metallic structures which are provided on the end fittings of different power system components, and which will prevent or try to minimize this extent of corona discharge. Then another topic was there, which was about the design and selection of the insulators, right? So these insulators, as I was telling, these insulators, as I was telling, uh, before commissioning it or before installing it on the actual power system network, we need to do some monitoring about the health of the insulation, about the performance. So by performance of insulation, what do you mean? Any idea? I'm telling this term multiple times about we need to test the performance of insulation. What is meant by performance of insulation? Any idea?
Should not fail under adverse conditions.
Yes. What do you mean by adverse conditions?
Like
What are the
rain, fog,
Yes,
pollution,
correct.
switching
So
surges.
yes, correct. So this performance of the insulator means it should be, what is the main function of an insulator? It is to withstand high voltages and insulate the phase conductors in the transmission lines, right? So basically it should be able to do that, and we should, like, we are developing newer materials, like newer composites which we are using for the design of this insulator. But we are doing it theoretically. We are saying that yes, this material can be able to withstand this much amount of voltage. But after designing, we need to test them under different conditions. So in the lab, it is a controlled environmental condition. Under that, first we test how much voltage it can withstand without breaking down. Again, we try to simulate as far as possible close to the natural conditions what is the breakdown strength of this insulator under different natural conditions, like when the pollution will come, like we coat these insulators with different kind of agents. The polluting gases, we know what will be there on the insulators if we expose it to outside atmosphere. So basically we prepare those different components and we coat it on these insulators, and then we apply different kind of voltages, DC voltage, AC voltage. Then we test it against impulse voltages also. So we generate these voltages artificially in our laboratories, and then we test the insulator. So that is one of the electrical criteria or the electrical design criteria of insulators. Then we have another which is known as the mechanical design criteria. So this mechanical design criteria, I'll not talk about it much because it is much related to the this mechanical loads. It should be able to, this insulators, the mechanical strength of the material should be high enough to withstand the load or the weight of the transmission lines, the towers, all these things. So basically you can go through the lecture and you can get back to me if you have any doubts. So this is about lecture 4. Next we have lecture 5. So in lecture 5 what we have, we have the non-ceramic insulator and its performance, service experience. So this is a brief outline of the course of first week. So now almost 1 hour is over. So now I'll take questions from you and I'll try to clarify it. Any questions? Anyone? About everyone has submitted the first assignment?
Yeah, the assignments are not submitted.
Yes.
The one question is, you are given the aluminum content in the composite insulator.
Can you repeat it once again? Can you repeat your
Alumina,
question?
the percentage of alumina in the insulator, some percentage 20, 30, 40 not given. But that depends on the different manufacturers, no?
I'm not able to hear you properly. Can you speak it clearly?
See, it is given the alumina content in the composite insulator, sorry.
Okay. Okay.
So that depends on the manufacturer, no?
Yes, correct. So that is basically one manufacturer we have given. That is a standard content. So basically, it will vary. Obviously, you're correct. It will vary from manufacturer to manufacturer. But we have given one standard. Professor has given one standard content of one manufacturer which he knows. So obviously, that will vary from manufacturer to manufacturer.
Okay. One more question.
Yes.
Surge impedance is given as 250 ohms actually
Yes.
in the lecture. But that will be very with respect to the different voltage levels.
No. Surge impedance, how can you?
No,
yes.
that is from 200 to 400, the values are given. I mean, vary surge impedance. The surge impedance will be vary with respect to different voltage levels. That depends on L and C.
Yes, correct. What is that L and C?
Inductance and capacitance of the line.
Yes. Yeah, of the line,
but,
correct.
Yeah. But the problems are solved with respect to 250 ohm.
Yes, correct. 250 ohms is the standard characteristic impedance of the surge impedance of a transmission line. So
the value is correct, but it will be very with respect to different voltage level. Slightly, not much.
How can you explain how it will vary with voltage level?
Yeah, that depends on the inductance of the line and capacitance of the line. For 11 kV
Yes.
lines, 750 kV lines, 400 kV lines, the values will be changing.
No, the inductance and capacitance of the line, on what it will depend? Will it depend on the voltage level?
That is, we'll be doing some dimension, no?
Yes,
So
correct.
when we see the formula, inductance and capacitance, dimensions of the line.
Hmm. Yeah, dimensions of the
Not,
line, right?
yeah, slightly it will be varying. Of course, your 250 is I accept it, but still I'm just giving this.
But actually, this inductance and capacitance of the line, what it will depend on, you have an idea? It will depend on the GMD and GMR, right?
Yes, spacing, all these things.
The spacing and all these things.
Yeah,
So,
system line configuration. That is single circuit line or double circuit line. The standard. How bundles? How many subconductors are there? Okay.
Yes, correct. So I didn't get how it will vary with the voltage level. Then you are telling these dimensions will be
See, 11 kV system, one configuration is there. 70 kV, one configuration is there. Obviously, the values will be changing. But the range is going to be around 200 to 400.
Yes, correct. That is what 200 to 400. But generally, for solving numerical purposes, we take it as 250 ohm.
Okay, fine. Next, is there any relation between right of way, that clearance, and the percentage power loss?
Right of way and percentage power loss.
Power loss. Okay. Suppose if you want to compare 400 kV line and 750 kV line right of way. In that
Obviously,
case,
there will be a difference. So, what is right of way? First of all, can you tell what is right of way?
Yeah, this tower. It's going to be width. It's going to be width. Tower. Right of way.
No. Right of way. What you are telling? Width of the tower.
Yeah. Width of that is at the base.
No, right of way is the clearance, right?
Yeah, clearance, right.
So it is not the width of the tower. So you have these transmission towers, right? UHV and EHV towers. So if it is a 765 kV, say it is carrying a 765 kV line. So that 765 kV line, it will obviously generate some dynamic electric and magnetic fields around this transmission line conductors, correct?
Yes.
So depending on this voltage level, the strength of this electric and magnetic field will vary, right?
Yeah.
So you tell me one thing, suppose the 765 kV line is running and one person is just standing beneath it, right? So there will be obviously some interference will be there and the person can get injured, right? So, so what do you think is the main cause of this injury? Means why is it caused? Is it because of the voltage, or is it because of the current, or is it because of something else?
The object will be acting as a capacitance.
Yes, correct.
Yeah, obviously the person who is standing under the line may get some twinkling of fingers, all these things.
Yes. So why means actually what is causing this harm is this high voltage lines. Actually, you need to have some clearance to construct some buildings or houses from these high voltage towers or lines, right? So basically, it is because of the strength of the electric and the magnetic field which is being generated due to these voltages.
Yeah, that is fine. Yeah. See, I want to know about the assignment is given comparison of some, I think 400 kV and 750 kV. Some two voltage levels are given to compare the respective right of way. But it's asked true or false, but I don't think so. It's a numeric comparison. Depends on the line, each values are varying.
Okay, actually I have not designed the assignment. Some other student, I'll talk and I'll get back to you. What I can tell is for the different voltage levels, there will be obviously a difference in right of way. Because
that I accept it.
Yes, correct. So any numerical comparison is possible or not? I'm not aware of that. I'll get back to you.
Okay. Thank you.
Thank you. Any other doubts? Anyone? Any other doubts?
Right of way also depends on the configuration of the transmission line, whether it is double circuit, multi-circuit,
Yes.
and the voltage, all that. Because the width of the right of way depends upon all that. It is not
Yes.
only the width of the tower, can be much more than that. It can be much
Yeah.
more.
Obviously. Any other doubts or clarifications? Anything?
Earlier, there is one more doubt. When the voltage, high voltage system, where the system voltage is very high, the capacitance, it will be dominating more than that of the inductance. Therefore, the
Yes, correct.
characteristic impedance or the impedance behind this one, it should be varying it. It cannot be 250 ohm or
Uh,
for a low voltage, it will be maybe more, or higher voltages will be less. Isn't it? Because of the capacitance, it's a dominating, especially in the ultra high UHVs, and inductance
yeah.
will be less compared to the capacitance.
But I think this capacitance you are telling the from the line to the ground capacitance, right? It is not the capacitance of the line you are talking about. Hello?
This is a line-to-line capacitance as well as the line to ground.
But line to line capacitance, will it vary? What do you
Yeah,
think?
it is the formulas. If you are taking it, it varies.
Yeah, for that actually there is a range of characteristic impedance given 200 to 400 ohms, right? So for numerical purposes, for calculation, basically if it is not told is a problem, we take it as 250 ohms. But yes, it will obviously vary with the voltage levels also.
I may suggest that
Yes, sir.
what we are looking at here is a surge impedance. And the surge impedance, I think the characteristic impedance of the line, that the reactance, capacitive, the steady state, those are steady state conditions. Those are not coming into play in the surge impedance characteristic. So to confuse that with the surge impedance seems to be wrong, but I am open to correction.
Yes,
The,
I
the
was
steady
also.
state, the steady state reactive and capacitive, reactive, inductive, and capacitive impedances are not to be confused with the surge impedance, which is a different phenomenon.
Yeah.
Consider
Yeah.
that.
Yes, 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 you are correct, sir. Anyone wants to share anything else? Any clarification? Any doubts, any clarifications anyone needs? Any doubts you can tell me, otherwise this session will go like this only. You have to ask some doubts, then only I can clarify. It's a 2-hour session, 1 hour I'll be talking, I'll be giving you an overview of the course, then you have to talk.
Professor Venkatesan was talking about the steady state at the transient. The capacitance and the inductance, I think it is do not vary with the this, especially anyhow transient conditions. Only the voltages it will be varying it.
Yes.
Therefore, this one mostly it is the because of the surge voltage spikes or oscillations. This voltage only it is causing the major damage in the insulators. Where the
So,
capacitance and the capacitance inductance we never calculate especially in the transient condition.
That is correct. So in the transient conditions, we don't calculate the voltages and this capacitance and the inductance. That is what you are trying to tell, right?
Yeah, that is right. It is only steady state conditions we calculate. But but the voltages and variations, it is because of the surges.
Yeah,
Surges,
correct.
it is coming in various type of surges. It is traveling on the conductors.
Professor Venkatesan, you want to add anything?
I am in agreement with that. We cannot confuse the surge impedance with the steady state conditions. They are used more for fault calculations and so on, steady state faults and fault calculations and so on. But when it comes to a matter of surge, it depends upon more upon the surge characteristic. And most lines, regardless of voltage, they fall into a band that you call as 200 to 400 band in the surge impedance. As far as surge impedance is concerned, it's a transient phenomenon. The transient phenomenon and cannot be directly compared with the steady state conditions.
Yeah. Okay. Anything else anyone wants to tell? Any other clarifications, any doubts, other students, please participate in the discussion.
Just I would like to know about the grid capacities, where most of the major power stations, it is centrally somewhere in Madhya Pradesh, UP, whereas the power requirement is more, especially in the western states, that is in Gujarat and Maharashtra, and southern also.
Okay.
But the southern, it is mostly the idle projects are not much compared to the thermal. Most of the power plants is the thermal power stations compared to the idle. Idle is less.
Okay.
Therefore, how the power it is being evacuated, especially from the south, or it is needed?
I couldn't get your question. Can you come back once again?
Whether the southern grid, whether it is a power is excess or it is power is deficient. First, that is a question. Compared to the western grid.
Okay. Oh, you want to know whether there is an excess or deficit of power in southern grid, right?
Yes. Yes.
Okay. That data I don't have actually. I cannot tell correct right now, but I'll talk with my professor, Professor Subbareddy. He is more into this practical applications of this. So I'll talk with him. I'll note down your question. I'll talk with him, sir. Anything else you want to know?
And whether the climatic conditions, how it is going to affect the power generation.
That is correct. Yeah, obviously. You want to know generation or transmission? You want to know transmission of power, how is it affected by weather conditions, or generation of power?
Okay, rainy seasons, hydel power stations where it will be generating more. That is the only season wise. But climatic conditions, how it will be vary. Climate, it is something else. It is compared to the seasonal variations.
Okay, climatic. Okay. Okay, fine. I'll note down your question. I don't have much knowledge on these practical things, so I'll get back to you, sir. Any other doubts? Anything pertaining to the course? Any other doubts? The BTech students, the graduates, the undergraduate students, do you have any doubts? Yes, Dr. P. Balsalal, you can tell.
Yeah, you shared the PPT in the course material. Designing or selecting a suitable insulator, the highest system voltage, and then the to ground level, peak line to ground, peak value, sorry. So 66 kV and 240 kV, and the maximum value and all this. I think some numerical misprint I could see somewhere, and I think some calculation. So
Which lecture PPT you are talking about?
so which is given, that is the week 1, the last part.
Okay, week 1, lecture 5, right? Lecture 4.
I think 4. Design or selection of regulator, importance of grading, control, corona control rate. I think some numerical value or some explaining is okay, but some you can check it up later.
Okay, fine. I'll check it, sir. Any other doubts? Anything?
Sir, somewhere in the slides. Hello.
Yes, sir. Yes, tell me.
Somewhere in the slides I have read, in the initial slides, I've seen somewhere that the frequencies were also different during the in between these zones of electricity. You mean they are classified into south zone, east zone, north zone, no? Somewhere I've read that there was some before integration, before synchronizing all this.
Yes, yes, correct. That was just before the independence. It was developing that time. So there was all the grids were independent. The northern and the southern, all these grids were independent.
Yes, yes.
So that time there was some issue with the frequency. There was the frequencies were different. Yes, you are correct. So later on, now we have synchronized all these grids and we are delivering power at our power frequency.
Okay. So is there any reason that we have finalized to 50 hertz frequency?
No. Just you want to know why that only 50 hertz we have finalized, right?
Usually in some other countries there are some other frequencies like 60 hertz. Some people use, and most of them are 50 hertz. So I don't never got a proper reason why we have finalized why we have settled down on 50 hertz.
Okay, one of the reasons which I can think about now is this corona loss you have heard of, right? This corona discharge I was telling, which can occur adjacent to the conductor. And these conductors, this electrical corona loss, that will depend upon the frequency of the system. And we have an empirical formula for calculating the corona loss. And that shows a direct proportion and with the frequency of the system. And we have seen there that basically all over the globe we have two frequencies, 50 hertz and 60 hertz, right? 50 hertz in India and 60 hertz in the US or US. So
Somewhere
basically,
in the Western countries, yes.
Western countries also. So basically, one of the reasons which I can think about is the lower losses, this corona loss, which is dependent on the frequency. That will be lower if we consider a lower frequency. Maybe that is the reason. And you can tell why is it not even below 50 hertz. Yes, I agree with that. I'll see into it and I'll get back.
No, I have a different opinion.
Yes.
See, here it's a 60 hertz. Actually, the hysteresis and eddy current losses will be more compared to 50 cycles.
Correct.
And especially what my view is, if you are taking any materials, you say if it is old frequency is more, the material consumption will be less, especially in a transformer.
Correct.
Therefore, the saving in material in your equipment, especially the transformers, motors, and everything, if it is keep it at 60, the material saving will be there compared to the 50 cycles. Most probably that will be the reason the Western countries they may be going for a 60 cycles. It is my opinion. I am not sure of it.
Yeah, that can be. That seems logical. That can be one of the reasons. Professor Venkateshan, you want to add something?
I can only think that the flux density is what eventually results in eddy current losses and hysteresis losses. And given a voltage, when the frequency is higher, the flux density is lower. V by F is the ratio. Actually, flux density is lower and the losses are a little lower in higher frequency than given the same voltage for the same voltage. So I would think that the difference in 50 and 60 hertz are more a result of historical reasons from long back, the researchers that happened in various parts of the world. Now, those that followed the Commonwealth or the UK, they started off with 50 hertz, and we have been following that. Wherever Britain has been ruling earlier, in many Commonwealth countries, we have these 50 hertz systems, and US is also leading the research in electrical engineering, and they started off with 50 hertz. So I do not know that there is any very big reason, except that the synchronizes better with the clock. That is a very small reason, but it still does synchronize better with the clock at 60 seconds, 60 minutes, and all that. So that can be a reason. That one cycle, 60 cycle per second, is a multiple of this. So other than a historical reason, I'm not finding any. I don't know. I mean, I'm always open to correction, but this is my thought.
Yeah, this is. I also just found out. Just thought that it can be the corona loss, which will be reduced at a lower frequency, and hence we are going for 50 hertz. Maybe they have some other reasons, like you all said, for going to 60 hertz. Maybe there I don't know of any other deep reason. I'll see and I'll talk with my professor and I'll get back. Any other doubts you have, Samir?
As far as now, only this, sir.
Okay.
Also the insulators. Can we discuss the insulators also now, sir?
Insulators, specifically what you want, you can tell.
Actually, we were during our studies, we have read about this creepage distance.
Okay.
So this creepage distance, when during our when Subbareddy sir gave his video lecture, it was termed differently. I forgot what exactly the term was.
Term is creepage. Yes. Tell me.
My actual doubt was in that they have told us, actually sir has explained that the distance should be measured only for the insulators, not the end caps and the pins, the metallic pins. I was thinking that when these end caps and pins of an insulator are in a string, so even they will not act as a conductor. They also are insulators. So how come we not consider those in our calculations?
No, that is the general convention, I think. As far as I can recall, he has explained that the creepage distance is the distance which is between this along the insulator only, and he has not considered the end caps and the pins, right?
Yes.
So I think that is basically the convention. I cannot think of any other reason why we should not consider. Yes, correct, you are, that it is also an insulator. I think it is a convention. Still, I'll look into it. I'll note down your question.
Okay, sir. Right. Only these were my doubts generally. And
okay,
also,
fine, Samir. Any other doubts? Anyone? Any other doubts? Anyone? Any other doubts? Wait for 10-15 minutes. Then I'll have to, if there is no other doubt, I have to close the session. Any doubts? Anyone? You can feel free. You can ask. I'll try to answer. If I cannot answer, I'll note down and I'll get back to you.
Hello, sir.
Yes. Can you introduce yourself?
Sir?
Can you introduce yourself? Your name and...
Hello.
Yes.
Sir, I have a doubt in power system.
What is your name? Can you introduce yourself?
My name is Harish, sir.
Okay. You are a BTech student?
Yes, sir.
Which year?
Second year, sir.
Okay. You can... Yeah. What question you have?
The mostly distribution side, the kV will be 11 kV, 22 kV, that is the kV. What is the specific reason the multiplied by 11, sir? Distribution.
No, 1 second. Can you repeat the question? Your voice was breaking.
In the distribution side, most of the kVs were multiplied by 11. What is the specific reason for that, sir?
The voltage level in the distribution side is, why is it a multiple of 11, right?
Yes, sir.
Okay. So, I'll think of it. 1 second.
Yeah, I'll give the answer.
Yeah, you can tell.
Yeah, yeah. Actually, the drop in voltage drop is going to be 10%. If you would like to have 10 kV, I should go for 11 kV.
Correct. So
That
yeah. I was also thinking of that only. So basically the form factor, right? This is the form factor.
then not form factor. As per the design, we are going. My requirement is 10 kV. I should go 11 kV.
Okay.
Means 10% voltage drop. So nothing with form factor.
Okay, fine. So basically this voltage drop he is telling. So this 10 kV, if you are wanting to send, if you are wanting to transmit at 10 kV, we'll have a 10% drop. So we'll not get an exactly 10 kV. So to get exactly 10 kV, we are transmitting it at 11 kV. So that even if there is 10% drop, we will get a net voltage of 10 kV.
I think his question is not understood, I suppose. See, he is asking 11 kV systems are there, 33 kV, 66 kV, 132 kV, it's all multiples of 11. Now, why is this, what is the reason for this multiples of 11? That is 11, 33, 66, like that.
Okay.
It is mostly because of the standardization, because the standardization should be so that all the equipments, different manufacturers, they are adopting that system voltages. Otherwise, if different voltage equipments are coming, it's very difficult to put it in one grid or one power system. That is because the standardization.
Okay, for standardization.
Standardization, the people more or less they accepted for these standard voltages all over the world.
Okay.
Okay.
Thank you, sir. Anything else? Any doubts?
Sir, you were telling about the form factor, because even I remember something like that. The form factor of a sine wave.
It is 1.11, right?
Yeah,
I was also
1.11. So I remember that the voltages when multiplied, it should be multiplied by this.
I also read it somewhere. That's why I told. Maybe. Professor Raju.
It would be better. Yeah, it would be better if you can try to research a little bit more about this topic, sir.
Okay, fine. Okay, sure. I'll look into it.
Thank you. Yes, sir.
Anything you want to know? Any other doubts? Anyone? Any other doubts? Anyone? Okay, fine. If you don't have any other doubts, I'll close the session today. Again, we will meet on next Saturday, 6 o'clock in the evening. Is it fine?
Okay, sir.
Okay.
Sir,
thank you.
Regarding this
Yes.
assignment, hello.
Yes.
Actually, we have submitted it once. Can we submit again with making corrections,
No.
or is it not valid?
No. It is you have to submit it before the last date only. You cannot do that.
Okay. Because I have submitted it, but now that means it is finalized, finished, right?
Yes.
Okay.
Okay. So before the next class, you should go through the second week's course and you should submit the second week's assignment and you can come back with any doubts. Meanwhile, I'll try to clear whatever doubts I couldn't clear today. I'll try to clear that. Yes. Fine. Okay. Okay, fine. You can leave. Thank you.
Thank you, sir.
Thank you.
Thank you, Farhan.
Thank you, sir.
Thank you.
Thank you. Thank you.